Welcome to today's live training seminar. My name is Miles, and with me today I have Alan. We both work in the Redlands campus at ESRI. The title of today's seminar is the Introduction to the ArcGIS Mobile SDK. So the seminar overview for today is that we're going to cover 4 key topics. We're going to quickly jump in and have a look at Mobile GIS and some of the technologies. We're going to move on to an introduction to the SDK itself. We're going to look at the workflow it takes to set up ArcGIS mobile deployment. And then we're going to look at designing mobile applications themselves. The format for today will consist of a lecture, a set of slides, and then we'll jump into a Q&A session and some demonstrations at the end of each section. Okay, so Mobile GIS overview. In the past, a lot of the field data collection that's been performed has been paper-based, whether it was people filling out forms in the field or perhaps taking large paper maps out and marking up the maps. And over time, with the development of GIS technology, we've seen major advancements in this area. Specifically in the last 5 years, we've seen a lot of new tools available for leveraging GIS technology out in the mobile environment. You can think of it as Mobile GIS as really an extension of the GIS beyond the office into the mobile environment. The Mobile GIS really enables the kind of information workers to capture and store. They can update and manipulate geographic information out in the field where they need to, when they need to. In return, the enterprise itself can leverage this GIS technology to really ensure the currency of the business information, to make sure at all times the enterprise has a good picture of the status of all of the objects or events or things that they are really interested in. As part of a successful mobile GIS deployment, there are really 3 key technologies that we need to understand. The first are the mobile devices. In the last 5 to 8 years, there have been huge advancements in mobile device technology. Today we have a range of different devices that we can leverage out in the field. They range from very small, mobile, easy to use, smartphone type devices right up to extremely powerful, sometimes a lot larger tablet or laptop PCs. The majority of our mobile GIS technology works within the Windows environment. So when we talk about devices, we're really speaking about Windows mobile devices and Windows desktop devices. The second key technology has been the development of a range of different positioning technologies. The most important one, of course, is the global positioning system. Over the last 20 years or so, we've been leveraging GPS in a number of different industries, and mobile GIS is no different. Today, there are a lot of different forms of GPS that you can leverage, whether it's the autonomous system itself with consumer-style chipsets, which provide accuracies that range from probably about 5 meters up to 20 meters, right through to very professional systems available from some of our partners who develop systems designed purely for GIS data collection. They would leverage differential correction services or additional services that enhance the accuracy. We also have seen major advancements in the area of wireless connectivity. In the past, a lot of our mobile GIS deployments have worked in a disconnected fashion. Today, we have the technology, especially in the wireless space, to be able to connect to servers and synchronize data over the wireless. 2 of the key areas in the wireless space that are important for us to track are Wi-Fi hotspots, or the 802.11 technologies, but also cellular data technologies. We now have the capabilities to synchronize data or push data over the cellular systems. And really the 2 main differences you need to consider between these technologies. With the Wi-Fi hotspots, we have very high bandwidth but limited range. Often that might be up to a maximum maybe 15 to 20 meters range around a Wi-Fi hotspot. This is great for supporting somebody who wants to work in a kind of nomadic style mobile GIS deployment where they might take their application and their device and their data out, perform their job, and then when they can, get access to the Wi-Fi hotspot and synchronize back the data to the office without having to actually physically go back to the office itself. The cellular data services provide us with a more seamless coverage. Bandwidth is definitely not as high or as available as what we have with the Wi-Fi hotspots, but the coverage is much better. So this is really good for a mobile GIS deployment where we want to constantly synchronize and push small updates back to the office in near real time. So let's just jump in and take a quick look at some of the devices themselves. So I mentioned smartphones, pocket PCs, and tablet PCs. As you can see from the slide, there is a major difference between the screen real estates and the form factors of these devices. At the high end and the tablets and the laptops down the bottom, you can see they've got very large screen real estate. Some of them are rugged, some are consumer. In the pocket PC space, we have the same break in terms of having consumer and rugged devices, but you'll see that the screen real estate is much more restricted. One of the key things that's common to these two types of devices is the touchscreen. So when we're developing mobile GIS applications, it's important to understand that we can leverage the screen and the stylus or the pen with these types of devices. The smartphone itself is very different in that it has a much smaller screen real estate, but most importantly, it doesn't have a touch screen. So when it comes to developing applications, as we'll see further in the presentation, you need to leverage menus and really the hardware inputs to control the application. Okay, so following on from that, we're going to now look at the SDK itself. We're just going to cover a quick introduction to it, and then we'll get into a wonderful demonstration. So the ArcGIS Mobile SDK is available at 9.2 as part of our ArcGIS Server product. ArcGIS Server is a complete and integrated server-based GIS. The product itself provides us with very rich developer ADFs or SDKs, but also an out-of-the-box experience. We have both applications and services that can be controlled very easily from an end-user standpoint without having to perform any sort of development tasks. The server itself, very much like our desktop products, provides three core capabilities. First is the spatial data management, storing the spatial data and managing the storage of that data inside a relational database. Obviously the visualization and mapping, both in the 2D and 3D environments, and of course the spatial analysis that we can perform in terms of modeling against the data and leveraging the visualization to really highlight the results. As you can see from the slide, we also have a range of clients now that work against ArcGIS Server at 9.2. Not only does our ArcGIS Desktop, really our flagship product, work against this, we also now have ArcGIS Explorer, which is a Windows-based application that provides a very rich 3D experience for consuming globes from the server. We also have web map applications. You can think of these as very simple and focused applications that can be deployed inside the browser environment, and they work in an always connected fashion. And of course, most importantly for this seminar, we have our ArcGIS Mobile developer toolkits, the software development kit today. As part of Server, we do not provide applications in the 9.2 release. Okay, so let's look at these software development kits in a bit more detail. In terms of the server, when you purchase a server, you get access to both .NET components and Java components. We have a web ADF, a mobile SDK on the .NET side. On the Java side, we have a web ADF and an enterprise ADF. The important piece here to understand is that the mobile SDK or ADF is only available in the .NET environment. Okay, so in summary, we have the ArcGIS Mobile SDK. It's a developer solution for mobile applications that's shipped as part of ArcGIS Server. And it's a suite of .NET components for developing custom server-centric lightweight mobile applications. Some of the key features that we have available within the SDK itself, we really support three main field workflows. As an application developer, you can deploy very simple, rich viewing applications in the mobile environment. You can also deploy feature inspection or basic data collection applications where not only are we going to sync out data from the server and view the data itself on the mobile device, but we can also interact with the data in terms of updating attribution, but also geometries. We have direct synchronization with the server itself, so we can request and post data back to the server. We work in both connected and disconnected environments. So when the SDK was designed, it was understood that many of our users and customers wanted to deploy mission-critical applications. To support this, we needed to not only be able to connect to the server, but also to be able to cache the data locally, so that if we didn't have current connection to the server, maybe we're working using a cellular data service and we moved outside the coverage area, the person who's using the application still needs to be able to perform their daily tasks. And the SDK has been developed around the Windows mobile and desktop platforms. Okay, so I'm going to pass over to Alan, and he's going to show us a wonderful demonstration.
Thanks, Miles. Okay, let's start by looking at some different variations of mobile applications. This first application is a Pocket PC application. It's running now through an emulator, and this is called a building inspector application, and it's really as simple as that. It's designed for somebody who's out in the field, who's out on site looking at buildings and inspecting them and then sending data back to the back-end server. So as you can see, right now we have this device up and running, and just to support some of the concepts that Miles was saying, this could be running in either a connected or disconnected mode. If this is in fact disconnected at this point in time, then the user can still use the application just like I am here. So even though we're using an emulator, this is running exactly as it would on a hardware device. Okay, so just a couple of things. We have some basic map tools down at the bottom if we want to do any mapping operations. But what we're really interested in today is working with this small device and interacting with the data. So again, the Pocket PCs have the ability to tap on the screen. So here we're tapping on the screen and picking up a building. So that building is actually, information is coming from the local cache. So we're on site now, and actually let's just pretend this is myself, and I'm going to make a statement here that geotechnical evaluation is needed, and I'm going to say that I'm going to limit entry to this particular building, and the date is today's date. Let's move forward here in our calendar, and I'm the inspector, and because I'm not a geotechnical person myself, what I'm going to do is I'm going to write a comment here. I'm going to send for Miles. Because Miles is also out in the field using a mobile device as well, and we'll see how that works in a second. So what I've done is I've updated the data on this local device. Now what I need to do as a worker out in the field is send this information back up to the server. So I do that just by synchronizing with the server. So I can have this program do it automatically, and here you can see the progress bar showing us that it's getting updates and actually synchronizing with the server. While that's going on, let's take a look at what Miles is doing out in the field. So here's application number 2, if you will, and it's, again, another building inspector application, except this time the application is running on a tablet PC. And it basically has the same interface. As you can see, it's slightly bigger, and most of the controls are the same, has some buttons instead of menus down at the bottom. Basically the exact same application. So the first thing that Miles needs to do if he's out in the field is he needs to synchronize his data with the server data, because it may have been updated, and sure enough, I have updated. So we can see here that this building, if we just pick on it, is the building that I went and made the recommendation inspection information for. So here we have my recommendation, limited entry posting, and so forth. So Miles sees this, and he's out, with his tablet PC, and he's like, well, you know what? I'm actually going to restrict use to this building, and he is actually not the geotechnical person, so he's going to send for Fred. And Fred is our back office person who will be looking at this information as it's coming in. So we'll leave the same date, and we'll change the inspection person to Miles. And we're going to save that information. You can see the color of the building actually changes over here to represent that our posting changes. Okay, so now we're going to synchronize that information, and you can see that happen quite quickly to our back-end server. And again, this is hooked into ArcGIS Server and version SDE on the back end. Now, let's take a look at this data from another angle. So here's an example of ArcMap just running, accessing the same data that the mobile applications were accessing. Again, the SD version data. So what I can do is zoom into that area of interest. And we can see that our building now has changed color, and it actually matches the building from the last posting. So what we can do is use all of the features of this thick client, ArcMap here. We can pick on that building, and we can see all of the information for it. So the building inspection information has been relayed here. It's setting for Fred, and he's our geotechnical person. And here's the recommendation, and it's been set to restrict use. So you can see the difference between sort of the heavyweight backend application like ArcMap and some of the lighter weight mobile applications. Here we have access to all the various fields and information, whereas in the mobile application we're simply restricted to these drop-down menus that we're working through domains and so forth. So just a quick demonstration that basically supports the concept that Miles went through in terms of being disconnected out in the field, either with a tablet PC, like in this Windows Forms-based application, or out in the field with a pocket PC, or again, this could be just a standard smartphone, and then making some changes to the data, saving them locally, and then synchronizing them with the database on the back end. So there's an example of the mobile SDK in action.
Thank you for that, Alan. Okay, so we're going to move on now and just do a quick recap and then a Q&A session. So if you have any questions, please send them through now, and Alan and myself will do the best to answer them in a second. So in the first section of this seminar, we've covered a quick overview of mobile GIS and the technologies. We've looked at some of the capabilities of ArcGIS Mobile. We've kind of highlighted the synchronization with the server, which Alan just demonstrated to us. And then we've touched on how the SDK is really about building and deploying simple and easy to use mobile applications. Okay, so I'm just going to take some questions right now. And I have a couple of great product segmentation questions here. I have one from Anne in Reading, and her question reads, is there a browser-based .NET mobile solution as opposed to being a smart client? And the quick answer to that is no, we currently don't have a browser-based technology for a mobile deployment. The majority of our efforts is going into developing around the smart client technology or concept that Microsoft promotes. We've got a second question here from Mel in Mesa, and it reads, we just implemented ArcGIS Server 9.2 workgroup standard. Can we build any mobile apps with this addition? Okay, so the answer to that is that the Mobile SDK is available as part of ArcGIS Server Advanced Enterprise Edition. So no, you cannot develop mobile applications to work with the Workgroup Standard Edition. You must purchase ArcGIS Server 9.2 Advanced Enterprise Edition. As part of that, you'll get 50 deployments bundled up with that edition. And if you want to deploy more SDK clients against the server, you can purchase them in packs of 25. Okay, and a third question here from James in Ann Arbor. Is ArcGIS Mobile an ArcPad replacement? How does ArcPad integrate with this SDK? So today, ArcPad is our rich, out-of-the-box mobile GIS application. So the mobile SDK is really about a developer experience. So you could almost look at this as being not a replacement for ArcPad. Now, do we integrate with ArcPad? The answer to that is no. There is currently no integration story between the ArcGIS Mobile SDK and ArcPad itself. They are independent products at the 9.2 release. Okay, I'm just going to switch back to presentation now. And in the next section, we're going to take a look at the ArcGIS Mobile workflow. So there are really three key steps to setting up and managing an ArcGIS Mobile deployment. The first is to set up our ArcGIS server. We're going to design and build a geodatabase. Perhaps we might want to optimize the geodatabase for mobile to really eke out the best performance in terms of synchronizing data over a wireless connection. We might want to replicate or ETL some data from existing enterprise databases or servers, because we might have a field team or a mobile team within our organization that is responsible for collecting data for all aspects or all groups within the enterprise. We also need to author a map. As part of this process, deploying for mobile is very different than developing for desktop, and as we'll see in a moment, we need to author our map specifically for a mobile. And the third piece there is we need to serve this mobile map up as a service. We need to create the web service so that we can enable the synchronization between the client application and the server itself. The second key step in the workflow is to develop our application. So we're going to go through a process of designing and building a mobile application around the SDK. And we might want to integrate in some other core mobile technologies. Maybe we're going to leverage some external sensors or some APIs that exist inside the Windows Mobile operating system. We might even interface with another mobile database system. And the third step that we shouldn't overlook is how we deploy our mobile GIS solution. So obviously we're going to develop our application. We might also want to create a map cache. We might want to pull some of the data from the server up front and create a package together that we then would deploy onto numerous devices before our field crew or our mobile information workers take them out and perform their day-to-day tasks. Okay, so let's have a top-down look at this and the pieces that are involved. So we're going to leverage ArcGIS Desktop. ArcGIS Desktop is really a control room application for managing ArcGIS Server. So we're going to build our geodatabase, author our map, and set up ArcGIS Server, and then publish our map as a web service. We're also going to leverage a sample application called the data extractor. The data extractor itself is built out of the SDK, and we'll see a bit more about this in future slides. But basically, it takes responsibility for synchronizing out a map cache that we're going to put together in the package that we're going to deploy out onto our mobile devices. And of course, the last piece of this is in the application that we design, we take responsibility for managing the day-to-day synchronization of the GIS data with the server. Okay, so let's look at each of these steps in a bit more detail. So in terms of building a geodatabase for mobile, you're going to leverage Arc Catalog. So within Arc Catalog, we might create a new database specifically for our mobile deployment and set up the schema. If we were to do this, one of the things we might want to consider is how we optimize the storage of the data inside the geodatabase. Obviously, if we're going to store lots of text fields, it might not be the most efficient way to synchronize data between the server and the mobile client. We might want to look at leveraging lots of domains to really minimize the way we store the data and how we push the data out over the service. The second piece of this is authoring the mobile map. Today, we're all very experienced with developing maps for desktop or printing style applications. In the mobile space, it's no different. We have to leverage the tools that we have inside ArcMap to develop a map that suits the needs of the mobile information worker when they're out in the field. So some of the things we need to take into consideration are obviously the screen real estate and the resolution of the devices that the map's going to be displayed on. Obviously, they're much smaller than what we have in the desktop environment. Pocket PCs run at about 320 by 240, so a lot smaller than our desktop resolution. We also need to take into account the type of environment. You know, what's the level or strength of the sunlight out in the field? Obviously, it varies. So we want to use very simple and easy to view and understand symbology within our maps. So we might want to deploy just a couple of background layers and a couple of edit layers and really use very simple and clean symbology. The third piece to this is also the scale dependencies on the layers. Obviously, if we want to create the best drawing performance of the map on the mobile device, we need to make sure that we are very in tune with the different scales that we want to render each particular layer. And we'll see a bit more of detail of this when Alan shows us our next software demonstration. The last piece of setting up the server is obviously to publish the map as a mobile map service. And Al's going to step us through that. You'll see that it's a very easy process to enable mobile data access and expose the web service. The second step to our ArcGIS mobile deployment is to really design our applications. So the SDK is installed as part of your ArcGIS Server product. You need to leverage Visual Studio 2005. And in terms of the operating systems that you can deploy applications onto, we're going to run inside a Windows Mobile 5 for Pocket PC 2003, Windows Mobile 5 for smartphone, and Windows XP, sort of tablets or notebook style devices that are running Windows XP operating system. The SDK itself has been integrated directly into the IDE. It's a very seamless integration, very easy to use, drag and drop experience with lots of properties that you can leverage. We've really tried to make the experience for the developer as clean as possible. The SDK allows us to build very simple and focused user interfaces. One of the things that we need to be aware of is that many of our field workers just want to use a tool. They don't have to necessarily understand the complexity of GIS and what points, lines, and polygons are and how to edit geometries. We can provide them very simple tools to use. And the last piece of this is developing for the form and function. As I mentioned previously, a lot of this work comes in terms of how you set up the map. But when it comes to developing the application, you have to take into account what capabilities does the device have. So with our Pocket PCs, like I mentioned in one of the earlier slides about the devices, they have a touch screen, so you can leverage the stylus to pan or zoom the map. But on a smartphone, for example, they do not have a touch screen, so you have to leverage the keypad and the rocker and menu options to really control and interact with the map or any tools that you want to provide to your field workers. And the last step is to go through our deployment process. So not only are we going to design the application, and the end result of that's going to be an executable and a couple of DLLs. We might integrate with some existing solutions. We're also going to generate this initial client data, and I touched on the data extractor previously. Today our wireless connectivity scenarios, although they're getting much better, we're still not at a point where we want to be pulling tens or hundreds of megabytes of data out over the wireless connection, especially a cellular data service. So to get around this, what we do is use the data extractor in the office to pull data from ArcGIS Server, bundle it up with the executable and DLLs, create this deployment package, and then we deploy it onto our devices. Now, there are a range of different strategies that you could leverage to deploy the package onto the devices. Many of us will be familiar with using ActiveSync, especially in the past with ArcPad. We've been deploying the application and perhaps the data from a desktop or a laptop to a device. So it's a one-to-one relationship. And we can pretty quickly deploy ArcPad and some data onto maybe 1, 2, 3, maybe 10 devices. But with the mobile SDK, we're now looking at very large deployments. And when you're getting up to thousands of devices, you need to really leverage some of the more professional systems that are available for synchronizing deployment packages onto these devices. A couple of examples of these would be Microsoft's System Management Server or SOTI's Mobi Control. Okay, so I'm just going to touch a bit more on the data extractor. This is actually a sample application built out of our SDK. So you can either leverage it yourself, or you could throw it away and start again and build your own extractor or integrate it into your own workflow. The extractor itself leverages the map components, the server component, the map cache component. We'll see more details about these in the next section. But basically the end result is we're building this mobile map cache which contains all of the data that we want to be either displayed as background or editable data up front. The final piece to the picture here is, of course, the synchronization. This is the real goodies of the system. Your application or yourself as the developer takes responsibility for managing the synchronization process. So as we saw in the demonstration that Al provided earlier, he had an option which manually or explicitly synchronized the data back to the server. Within the SDK, in developing against it, you can create a function that would automatically push the data back. It would take any of the deltas that exist in a specific feature layer then push it back to the server automatically. You also have to take responsibility for requesting or pulling down the data. So you might pass up a spatial or attribute query to optimize the data that you're actually going to pull out from the server itself. So with that in mind, I'm now going to pass over to Alan again, and he's going to step us through this workflow and all the tools that we use to achieve a successful setup for our ArcGIS mobile deployment.
Okay, thank you, Miles. So we're going to start here by looking at ArcMap, and what I'm doing is I'm loading up just a simple document. It's an MXT document, and I think simple is the key word here. So we'll look at a few things and how this document is different than maybe some of the documents you're used to authoring and working with inside of ArcMap. So to start, we have only 2 layers that are referenced here, and they're referencing back to SDE. And so we only have 2 layers, and you'll notice initially the symbology is very simple and it's very straightforward. So the parcels are color-coded sort of with this yellow to beige color, and then the buildings are also easy to identify throughout. And notice that we don't have a whole lot of other information or a whole other lot of layers available, so it's very simple. The second thing to note is the symbology. The symbology is very simple, and you'll notice that when you're reading through and starting to work with the mobile technology, that there's only a limited set of symbols that are supported, and it really makes sense because of the size of the device that you're working with and so forth. So that's all well documented throughout the SDK. The other thing to note too is this application is right now, as we're sitting, is zoomed into a location. So we'll actually zoom out and we'll contrast the difference in extents. If you look at the entire extent of this data, you can see there's really millions of features available through SDE. And on a mobile device, of course, if we look at the size of a screen, we're looking at about 320 by 240. So we can see, we'll recalculate this ArcMap screen to look like a mobile device. And you'll see that it's actually not really representative of what you'd want to see on the device out in the field. So what we'll do is we'll zoom into a more appropriate extent. And from there, now we're basically set to author this application up as a service through ArcGIS Server and SDE. So we'll save this document, and we'll move on to our catalog. Now with our catalog, actually there's a couple different ways we can publish services with ArcGIS Server. Probably the easiest way is through our catalog. So we're going to publish our MXD, and here we're just going to select the defaults. One thing that's really important is looking at setting the mobile data access checkbox here, and this is one of the capabilities that we're enabling throughout this service. What this is going to do behind the scenes is create a SOAP web service endpoint by which your smart clients can interact with this web service through. So if we pick on the web service, we can actually preview it here using our catalog as a client. And it's important to realize that here we're just looking at a very simple image that has been streamed back to this client through SOAP. So the actual features aren't present here. Okay, so what do we have so far? We have the data that's authored. We talked about the symbology. And then we talked about building this as a web service and publishing it for mobile applications. Now, there's a couple different ways we can go from here, but we want to show you at this point how to use the extractor application. And as Miles made mention of earlier, what we're able to do with this sample application, again, it's included with the SDK. You can download it from the Eden website, or it's also included with the product software. What we can do is communicate to the web service endpoint that we just created and extract data, and that data represents a map cache. So what I'm going to do is go back to the service that we just created, click on the mobile data access link. I'm going to copy that URL into memory. Okay, so now we have all the information we need. I'm going to paste that in. I'm going to connect via this URL to the web service that we just generated. So the extractor, the whole objective of the extractor is to work with that SOAP service endpoint and extract the data for the extent that you're interested in. So we'll just leave all the defaults here. and we'll hit extract, and we'll see what's happened. Well, basically, we've retrieved 73 buildings and 69 parcels, and it's built the map cache into this directory on the local machine. So if we just click on this link, this is our file explorer, and we can see that it's actually created 3 files. So we have the building inspection, the parcels, which represent both layers, and we have a map schema as well. So these 3 bin files together is the map cache. Now, we have lots of options at this point. If we want, we can package this up into a cab or go through single-click deployment, however we want to get it to our end user or end device. And we can package up this map cache and send it to the device if we want. Now, there's some other options, too, for extracting data. The smart clients have the ability of extracting the data on the fly, if you will. But we wanted to show you this extractor application and its purpose and its usage.
Okay, Alan, thanks for that. We've got a set of questions here, which I'm going to work through. So if you can, please send through any more questions you have right now, and we'll answer those the best we can. And we're going to do a quick review while those questions are coming through. So we've looked at ArcGIS Server setup. We've covered a little bit on the ArcGIS Mobile application development. We've looked at how you can deploy your Mobile GIS solution. So before we jump into the next section, we've got a few questions here. And I have one from Karen in Tallahassee. And the question reads, can ArcPad synchronize with ArcGIS Server the same as ArcGIS Mobile? And the current answer to that is it doesn't use the same synchronization method. ArcPad works in a disconnected mode. So when you're using ArcPad, you're going to synchronize directly with ArcGIS Desktop. But as part of that synchronization process, or the check-in, check-out process as it's referred to with Desktop, you can access data from within SDE or behind the server itself. So yes, you can get to server data from within ArcPad, but it's a very different mechanism for synchronizing the data. Its focus is really about disconnected workflows, whereas with ArcGIS Mobile, we're focusing a lot on the kind of wireless synchronization strategies. And I actually have a question here from Guy in Timaru, which I'm going to pass over to Alan. And the question reads, is the service XML only? So Alan, perhaps you can answer that for us.
Yeah, well, we have some different options with the communication protocol that's used, and I'll be able to show you that in a little while. We can actually set the default setting of the map cache so that it can stream just with standard XML, or if you want to use different protocol, well, like for example, packaging it up as binary. So binary sometimes ships a little faster and more efficiently, so we recommend that. So we'll see that option in the developer controls in the next section. Thanks, Guy.
Okay, so we've got a lot of questions streaming in here, but I've got one last one I want to do before we move on. And just as we go through this, keep sending your questions in. At the end, hopefully we'll be able to answer all of them for you. So I have one from Robert in Houston, and it reads, through ArcGIS Mobile, can you perform markups in the field and post markups back to your database? And you know, we have a lot of discussion with our customers and users about what people actually mean by markups. And you know, if you're talking about sketching on a tablet PC or a pocket PC, and really sketching on top of the map, the answer to this is yes, you can achieve it. With inside ArcGIS Server, you would just store a polygon or polyline feature class, which you would expose as your markups layer. And then within your mobile SDK development, you would create a simple sketching tool, which would store the geometry from the sketch into that layer or that feature layer that you've specified to be your markups layer. So to the end user, it feels like they're just marking up on top of the maps. And if you're on a tablet PC, for example, you could take advantage of some of the wonderful inking technology that's available with that operating system also. Okay, so we're just going to jump back into the presentation, and we're now going to move on and take a look at the features of the SDK itself. So the SDK was developed around or on top of the .NET Compact Framework 2.0. What this means for us is that we run, or it gives us the ability to create applications that will run on smartphone and pocket PC operating systems, mainly the Windows Mobile 5 operating systems, but also the old Pocket PC 2003. It also means that because the compact framework is a subset of the .NET framework, we can also run on the tablet and laptop devices. So anything running Windows XP, that would have the .NET Framework 2.0 running on it. From a development standpoint, you need to be able to develop against C# or VB.NET. You're going to have to leverage Visual Studio 2005. One of the key things to remember about Visual Studio 2005 is that when it shipped, it didn't actually ship with the SDKs for the Windows Mobile 5 for Pocket PC or for smartphone. So you need to go to the Microsoft.com website and download or access these SDKs and install them so you can successfully develop against our ArcGIS Mobile SDK. The final thing that you need is ActiveSync 4.1 or higher. The reason you'd need ActiveSync is that from a development standpoint, when you're coding and building and then deploying your application, you're going to want to push it against the emulator. So there's a set of emulators that come as part of the SDKs that you can use inside Visual Studio, and we saw one of those earlier, the Pocket PC one that Al used to show us our application. But to interface between Visual Studio and the emulator, you need to use ActiveSync. Similarly, if you're going to test and deploy your application on a real device, which we would highly recommend that you do before deploying it to your end users, ActiveSync is your mechanism for deploying or synchronizing the data or connecting with the device itself. Okay, so some of the considerations for the .NET Compact Framework. As I mentioned, it's a subset of the .NET Framework. So if we were experienced in developing against Windows XP inside the .NET Framework itself, when we move down and develop applications in the mobile environment, we'll quickly discover that not all the components or controls that you're used to using are available. So really it's been optimized for smart devices, and we've made decisions about what they're going to make available for you out of the box to develop against. So not everything works the same. That's really the key message here. And the way to deal with this is really just to read the documentation. There's a lot of wonderful documentation on the differences between the .NET framework and the .NET Compact framework. And I mentioned previously, obviously we need to leverage the emulators and the devices themselves to test and deploy. Okay, so some of the high-level features, or an overview of the features inside the SDK itself. It's a suite of .NET Mobile GIS components. It's designed for this client-server synchronization or client-server style applications. You can support multiple connectivity scenarios. We would talk about this as a kind of occasionally connected strategy where I might want to deploy a fully disconnected solution where I design the application so it pulls out or caches the data from the server when it's connected via ActiveSync against my desktop. Then as the mobile information worker, I'd take the device out in the field, perform my job, fully disconnected from the enterprise, until I come back at the end of the day and then resynchronize. You can go to the next step where I might have wireless access to hotspots out in the field, so I might build what we would call a nomadic style application where it can synchronize periodically throughout the day. And of course, the other end of the continuum is to develop a fully hosted or over-the-ear, always connected application where the user might actually access the application over the ear on their device, pull or cache the data from the server through the wireless, and then perform the job as they go. And they may even throw the application away when they're finished. The SDK itself was designed and developed over a couple of years, and two of the key things about it is that we developed with a very small footprint. So the developers in the team were very successful at keeping the DLLs down to about 500 or about 540 kilobytes in size. So that's huge when it comes to moving to the point where you want to do an over-the-ear deployment, because now it's very easy to push this out. Also, there's very high performance in terms of the rendering of the map and the performance of the map against on-site or in the smartphone and Pocket PC operating system. So we've done a lot of work in that area. Obviously, we've had experience in this with our past applications. So in the SDK, we've really churned on this, and I think you'll see there's absolutely wonderful performance in the way that we render the maps. And of course, the last and piece that should not be forgotten is our comprehensive developer help. So we've integrated directly into Visual Studio. So Alan will show that to us later on today, the controls inside the toolbox and how easy it is to drag and drop and work with them. We also have a set of walkthroughs and samples that come out of the box with the SDK. And of course, our online documentation. So you can access that online documentation from the ESRI developer network. So it's edn.esri.com is the URL to access that. Okay, so let's look at some of the core components. We've talked a lot about ArcGIS Server and exposing the web service. That's the first core component that we need. We also have a map cache component, and as part of the map cache, we have a server connection or capabilities to manage the server connection. The map cache really takes responsibility for storing all of the data published through the web service, and the server connection controls the way that we synchronize with the server. We use the server connection to manage when we want to request, create spatial attribute queries against the server, or when we want to post back just the deltas from the map cache. So we're creating edits in our application and pushing them into the map cache. When we post them back, we're going to call post on the feature layer, and it's only going to ship back the changes inside the map cache. The reason we've done that is we really wanted to optimize the performance and the ability to synchronize data back over very slow wireless connections. In terms of the way that we store the data inside the map cache, we support feature layers, annotation layers, and raster layers from the server. Of course, the feature layers are what we're going to edit against. And for the layers themselves to be editable inside the map cache, they need to come from a SDE source behind the server. So we can pull feature layers from a file geodatabase or an SDE, but we can only edit against SDE. And the reason for this is we're going to be in a situation where we're going to have multiple user editing, and we can't support that against the file geodatabase itself. We support annotation, so we can pull and render the annotation. We do not support editing against the annotation. And we also support pulling out the raster layers and creating the pyramids and being able to render really rich raster information on the mobile device itself. We have a map component. We can't forget about that. The map component works directly with the map cache. And it takes responsibility for rendering the layers inside the map. And on top of the map, we have a set of map actions that we'll look at in more detail. But these map actions are really tools that you could take advantage of to manage various things relating to the map. Maybe it's panning and zooming around the map or sketching against the map itself. Okay, and so we've also integrated in support for a GPS. So we have a GPS components. They support the NMEA protocol, so we can read from a serial port GPS connection or even a file GPS connection. So by that, what I mean is that we can take a text file that stores a set of NMEA messages, and we can read that in. That's very valuable for when we're developing or debugging our applications. We have a GPS display component, and this component really takes responsibility for listening to and managing or reading the serial port or file GPS NMEA messages that come through, and then rendering or displaying or providing some feedback on the map. So we read from the PDOP, obviously the X, the Y, and the Z location, but we also provide to you the number of satellites. And we've created a very simple symbol that sits on top of the map and displays these core pieces of information to you. It also takes responsibility or has the capability to pan or manage the navigation around the map automatically. And we have some navigation capabilities in terms of as the crow flies navigation. So you could pass in a coordinate and it would display to you a very simple navigation UI with the current arrow pointing to the direction that you need to head in. From the standpoint of using this, we tried to create it so it's very simple and meets the needs of the majority of our developers, but it's also developed from the standpoint that if you're not happy with the way that we've implemented support for GPS, or perhaps you're a vendor who's got your own protocols, then you can replace this and develop your own GPS connection components and also display components. Okay, so I mentioned that we can edit against feature layers. You'll see on this slide here, the way we've gone about this, or we've exposed it to the developers through the ADO.NET interfaces. So you can perform the sort of spatial and attribute queries on the map cache, so we can search through the feature layers themselves. The queries are executed against the local cache. You can also load the data directly into a feature layer data table, which is really just an ADO data table. And of course, the featured data reader if we really want the fastest or best, most optimal performance for reading large amounts of data. And of course, we support updating the map cache, and the way we'd update the map cache is through ADO. We would manage and take control of the actual feature layer and the records inside the feature layer that we want to work with. Okay, so let's look at some of the editing capabilities in more detail. Edits can be performed in a disconnected mode. So earlier on, I talked about the fact that we can work in this disconnected mode where we're caching the data locally on the device. So anytime in your application, as long as the cache exists, you can edit against it, provided the feature layers are coming from an SDE data source. We do require the connection to synchronize directly with the server. All the data transactions take place through the web service, so if you don't have access to the connection, then you can't post the updates back to the server itself. And we support editing for both non-versioned and version transaction models. We mentioned some of the map actions, and one of the map actions we've put in place is a sketching map action. You can leverage this map action. It's a very coarse-grained component. The majority of our customers and users or partners want to develop applications that, of course, have editing in it, whether it's creating points, lines, or polygons, or maybe modifying existing geometries. So the sketching component exists because we feel that the majority of our users want to leverage it, so we provide it to you out of the box. And as I touched on the last slide, all of our attribute editing occurs via ADO.NET components. Okay, so that was just a quick overview of the SDK and some of the components inside the SDK. I'm going to pass over to Alan, who's going to run us through a development scenario.
Thank you, Miles. All right, so let's take a look at some of the critical pieces here that Miles mentioned. So the first thing we're going to do is, let's just say we're an ambitious developer and we just want to start developing straight away with the mobile SDK. So we're going to pick a Visual Studio C# Smart device and the mobile Windows 5 Pocket PC device application. So we'll let Visual Studio go ahead and build that for us. And of course, it can do so because we've previously installed the .NET 2.0 Compact Framework. So that's what gives us those options in the Project New menu. Okay, so if we just want to start developing, a few of the pieces of the puzzle that Miles mentioned before we get started actually is looking at this device emulator. So we have this emulator that comes as part of the Compact Framework install, and here you can see we're connected to the PC emulator right now. So that's a bit of a pre-configuration thing. After you connect in Cradle, you'll see that you need to go to Active Sync, and as long as Active Sync is connected up to the emulator, because it is running right now, then that means I'll be able to run this application in real time. And it's actually going to run and deploy to this emulator device that is running. So that's a little bit of the background configuration that has happened here. Okay, so let's get back to development. What I'm going to do is go to the toolbox and look at some of the mobile controls that are available. So we have the map control, the map cache, GPS display, and then you'll see a number of actions down here. So we've got the scale bar, sketch, zoom in, and zoom out. So these are the basic tools that come as part of the SDK install. So what I'm going to do here is just simply drag a map onto our form that's available on the default form for this project. You notice that a map cache is automatically added. So one thing that's interesting is that as a developer, we can work with the map cache outside of the map, but you can't work with the map without a map cache, because the map cache is really the thing that connects you to the server on the back end. So let's take a look at that. So in order to make this project run and work, we need to hook the map cache up to a URL. So let's take a look at our service that we created earlier. We'll go to the properties. And again, we'll just copy this. Make sure we get the right one. The mobile URL endpoint. Okay, so we'll paste that in the URL property for the map cache. And then we're also going to specify the storage path location. Now this is the location on the device, and right now we're looking at the emulator as the device. Okay, so if we were to run this application, then we wouldn't see a map yet, and many of you may have run into this because there's a little bit of coding, more coding that's involved here. So what I want to do is point everyone to the ESRI Eden website. It basically has our EDN, and basically it has all of our walkthroughs and so forth that are set up. So here you can see we have a mobile ADF developer scenario. If you look down here, we're creating a mobile ADF Pocket PC. So it takes you through all the steps that I just basically stepped you through, and you'll see in the form load, the application needs to be told to load the cache or load the map if it has one available. All right, so what we're going to do is just paste in that code. So here we're looking at making sure the cache is valid. If it is, we're going to open it. We'll add a using reference to the project. Now you notice that there's only one assembly that's required to develop with the SDK. So unlike working with ArcObjects, you had many assemblies. Here we just have the one. Okay, so we should be ready to run this application. Let's do a few things more before we get going because we're running out of time here. What we're going to do is add some actions so people can actually interact with the application. So I'm going to add a pan and a zoom in out action here. Now these are the actions that Miles was making reference to earlier. We could do sketch actions. There's all kinds of custom actions that can be developed from the developer. It's essentially the same as implementing iCommand if you're an ArcObjects developer. So here what I'm going to do is just title the menus. And we'll go ahead and stub out the handlers for the menu. Okay, so what we need to do now is hook up the map, current map action to, in the first case, it'll be our zoom in out map action. We'll see how that works in a second. In the second case, set up the current map action to simply just panning. All right, so now we have some functionality to make our application work. Okay, so we have our emulator up and running. So if you're using an actual device, the device would be just sitting beside me and it would be cradled, and the emulator is simulating that configuration. So I'm going to start debugging, and you'll see what happens is when the project goes to build itself, what it does, it goes through and recognizes that in order for the application to deploy this to either a device or the emulator, that it requires the ESRI Mobile 92CE DLL. Now this is the DLL that will support the EXE, and that was the 540 KB DLL that Miles made mention of earlier. So this went through and did the compile. Now it's deploying, and we'll go back to our emulator device, and you can see that the application is essentially being uploaded or deployed to this device on the fly. So again, this is all working through ActiveSync and through the emulator. Okay, so here is the web service that we published earlier, and we can see that we have some functionality we've implemented. So our map action to zoom in, a little different operation than you might be used to. Here I'm actually tapping and dragging on the display, simulating using the pen device itself. If I want to pan over to the side, then I can change the action and just pan over to the map. So right now it's just feeding off of that map cache and drawing to the display. So this is a very simple application that illustrates, how to use the SDK, some of the components involved, including the device emulator manager, the ActiveSync, and basically how to bring the whole thing together with the SDK.
Okay, thanks for that, Alan. That was a pretty wonderful demonstration there. Very easy to get a viewing application up and running. So let's move on and finish up today because we're running out of time here slowly. We're going to jump into a quick review and then a question and answer. So this is your last chance. If you've got any questions, please forward them through now and we'll do our best to answer them in a second. So we've looked at designing mobile applications. We looked at some of the considerations in terms of the .NET Compact framework. We also covered the core components to the SDK itself and the editing capabilities. And then we saw a demonstration tying all these pieces together. So I'm just going to take a few questions. And I have a question from Spencer, and it reads, is ESRI planning on releasing a Java SDK for mobile applications. Now, the current answer to that is we don't have plans to do that. Our approach to this is to look at the demand for that requirement, and I think if we start to see lots of questions and customers who are demanding that we do a Java SDK, that is definitely something we would look at. So if you need to, feel free to, you can email me directly at msutherland, so MSUTHERLAND at esri.com. And if you have any requirements like that, I'd definitely like to hear from you. I have a question here from Chris in Greenwood Village. Are complex features, geometric networks, and tracing supported? So the answer to that today is that we don't support the complex features or the networks or the tracing inside the mobile SDK and its cache itself. But from a development standpoint, what you can do is develop a mobile SDK application that would interact with some of the geometric networks and perform tracing on the server side. So if you do have the connection, you can deploy that level of functionality. But that's currently something that we do not have in the client side of the SDK. I have a question here from Daniel in New York, which reads, which version of ArcGIS Server do we need to deploy mobile? And the answer to that is that today you need to purchase ArcGIS Server Advanced Enterprise Edition. And as I mentioned previously, with that edition you'll get 50 deployments of the SDK. And if you wish to, you can purchase additional packs of 25 deployments of the SDK itself. And I have a question here from Laurel, and the question reads, what if you have a large SDE raster, say 100 gigabytes in your MXD? This is a very good question, and you know, today in the way that the SDK is developed, a lot of the limitations come about because of the device and the operating system that we're running in. So today we definitely cannot support synchronizing out a 100 gigabyte raster through the web service. One thing that you could look at doing if you wanted to deploy from a service that had such a big raster in it is to chunk up the data as much as possible. But really, even if you're looking at 1 gigabyte of raster data is really going to be maxing out what you could store on a mobile device and operate against as part of the SDK. And I've got a question here from Christopher in Chicago. How easy is it to deploy both a PDA-based and tablet PC-based application, keeping the functionality identical? And the real simple answer to that is it's actually very easy. And the way to go about it is to actually develop around the Pocket PC platform first. Because the .NET Compact Framework is a subset of the .NET Framework, if you develop the app with the capabilities that are available inside the .NET Compact Framework, you could then very easily deploy the same application with the same capabilities on the tablet PC. Of course, I wouldn't necessarily recommend that you develop the same user interface for both platforms, so that's definitely something you might want to modify, because on the PDAs we have different ways of interacting with the devices, whereas on the tablets you can really leverage big buttons and leverage the stylus and the inking capabilities, so you might want to change the user interface experience. Okay, so I have lots and lots of other questions here. I'm going to take one more, and then we're going to finish up today. And the question here is another one from Chris in Greenwood Village, and it reads, while disconnected, does the cache expire? And the answer to that is no, it doesn't. The purpose behind the cache itself is really to store the data, but mainly so that we can operate in this disconnected manner. So if you lose connection to the server, the cache definitely doesn't expire, and when you regain the connection to the service again, you can just continue to post data back to that service, provided it's the same service that you were previously pointing to, or your application was previously pointing to. And by that I mean that the schema exists in the same form that it was previously. Of course, if you change the schema on the back end, then your cache will effectively have expired or no longer work directly with that service. Okay, so before we go today, I'd like to point you to a few resources. on the slide, you'll see that we've highlighted a few of these. You can access another virtual campus course titled Building Applications Using the Microsoft .NET Framework. We also have an instructor-led training course coming up, an introduction to ArcGIS Server. I would highly recommend you do that if you haven't had experience with a server product previously. And also, there are other resources available for you on the web. So, as Alan pointed out earlier in the session, there's the ESRI Developer Network website, which can be accessed from edn.esri.com. And on the slides, we also have 3 other great resources that you can get from our friends at Microsoft. You can read up on the .NET Compact Framework, ADO.NET, and mobile development and deployment. Okay, so your comments help us improve our seminars. Please take a moment to complete our survey. Just click the Give Us Feedback link to take the survey. We hope you enjoyed today's seminar. On behalf of ESRI, I'd like to thank you all for attending.